Shortly after the conclusion of World War II, the United States Air Force, foreshadowing the onset of the Cold War with the Soviet Union, embarked upon a research and development project to create a nuclear-powered aircraft. The rise of the Soviet Union as a world power in the Cold War led to the United States Air Force to consider the need for surveillance and bomber aircraft that could engage in long-term missions of up to 3 weeks airborne. The United States Army Air Force initiated the Nuclear Energy for the Propulsion of Aircraft program in May 1946, in which focus was placed upon reactor technology and energy transfer systems. This program led to the subsequent creation of the Joint United States Air Force Atomic Energy Commission program called Aircraft Nuclear Propulsion, or A&P, in 1951. Sufficient progress was made such that A&P had settled on 2 nuclear jet engine propulsion concepts to investigate further. First concept under consideration was a direct air cycle proposed by General Electric, and the second concept was an indirect air cycle proposed by Whitney. The direct air cycle was based upon a GE J47 turbojet engine in which the combustion chamber had been removed. After passing through the compressor stage, the air would be ducted to a 3 megawatt air-cooled reactor core located within the main fuselage. The air, now superheated after passing through the core, would then be ducted back to the turbine stage of the engine before generating thrust from its exhaust atmosphere. GE constructed and operated 3 ground-based prototypes as a proof of concept test. The HTRE-3 system had an adequate thrust to theoretically sustain a flight at 460 miles per hour for approximately 30,000 miles and was considered for the proposed X-6 bomber project. The direct air cycle concept was strongly favored owing to its use of relatively conventional hardware, simplicity, and reliability. The indirect air cycle incorporated a liquid-cooled reactor core utilizing either pressurized water or liquid metal, in which the superheated fluid would be pumped and piped to a heat exchanger located between the compressor and turbine stages of a jet engine. After being processed by the compressor stage, the air would be superheated by virtue of passing through the heat exchanger and exhausted to atmosphere after powering the turbine stage. This cycle was judged to be more technically challenging owing to the need for pumps and the heat exchanger itself. In September 1951, the United States Air Force placed a contract with Convair to modify a B-36 bomber to carry a compact nuclear reactor and heat transfer system. The B-36 was the only aircraft at the time that had the structural capability to carry the weight of the reactor, heat transfer system, and shielding. Modifications to the aircraft included a revised airframe in the aft bomb bay to accommodate the reactor, and a revised forward crew compartment that incorporated a radiation shield. The modified aircraft was redesignated as the NB-36A Nuclear Test Aircraft, or NTA, and its primary purposes were the testing of shielding to protect both the crew and avionics from harmful radiation effects, and to test the ability to maintain a controlled nuclear reaction on an airborne moving platform. The NTA performed 47 flights over West Texas and southern New Mexico between the summer of 1955 and the fall of 1957, with the reactor achieving criticality on many of these flights but not utilized to power the aircraft. By the late 1950s, it was judged that all significant technical issues had been resolved and that those remaining, deemed relatively minor, were capable of being brought to solution, and a practical military nuclear-powered aircraft was achievable. Ultimately, the program was finally canceled on 26th of March 1961 by President Kennedy, the victim of politics and technical advancements in other areas, specifically the development of an accurate, nuclear-capable intercontinental ballistic missile, which was less expensive, more reliable, and judged to have a greater survival capability in enemy airspace.